Hello and welcome to the MyHeritage webinar series. I'm Miriam Pierre-Louis, your host, broadcasting to you live from Eastern Massachusetts. Today we have Jennifer Patterson Dondero, who is with us live in Georgia for her class, MyHeritage DNA for Your Family Knot. Here's a description of our webinar today. If you have a lot of ancestors that married within the same group, but you're not an endogamous population, you can still have issues using DNA for genealogy. MyHeritage DNA has some of the best in-house tools for dealing with this, but you have to recognize the situation first. Thanks to Jennifer and thanks to all of you for registering for today's live webinar. So wherever and whenever you are, glad to have you with us. We're thrilled to introduce MyHeritage Education, a new online resource center for enhancing understanding of MyHeritage's tools, products, and services, and to help you make the most of your family history research. The website includes a wealth of educational materials that will help you learn about every facet of MyHeritage, articles, how-to videos, and the MyHeritage webinars covering a wide variety of topics, including plenty of tips for everyone. MyHeritage Education is currently available in 10 languages as well as English, of course. Find all resources at education.myheritage.com. And now to introduce our speaker. Jennifer Patterson Dondero is the author of the Occasional Genealogist blog and a professional genealogist for over 10 years. She specializes in DNA and Lineage Society application projects. Jennifer has an MS in Operations Research from Georgia Tech and a BA in Math and Economics from Agnes Scott College with a minor in History. Please put your virtual hands together and let's give Jennifer Dondero a nice, warm webinar welcome. Jennifer, how are you? Welcome to the show.
I'm doing great. Thank you.
Well, I am going to switch the controls over to you. You should see a little alert come on your screen.
So I am Jennifer Patterson Dondero. I had Jeff add in my middle name onto his slides. I'm so particular. I'm not particular, but I did want you to realize I am not genetically a Dondero. People ask me about my Italian heritage, and it's my husband's. And that is related to the DNA we're going to talk about today. This is MyHeritage DNA for Your Family Knot, and we are going to look at how you can untangle the branches of your DNA tree. So we have two parts to this webinar. First, I am going to talk about the family knot, and then we're going to talk about MyHeritage DNA tools. And Marion was asking me, is family knot a Southern term? My entire family is from not just Georgia, but from North Georgia. And so, you know, it's all Southern heritage for me. As far as I know, that is not the case. Maybe we say that more. It was a joke I made a number of years ago, but I could not find a good way to describe this situation. And if I say family knot, people usually say, what's that? And then I get the chance to explain it. So we are going to talk about what is a knot? What am I talking about in this situation? Why it's a problem and dealing with the problem. And we're going to do that pretty quickly. And then we're going to look at dealing with this particular problem using the MyHeritage DNA tools. We're going to look at triangulation. We're going to pull in some outside tools to also do inductive mapping. And then I've got a bit of a warning when you're dealing with a knotted family tree. So what do I mean by a family knot? It means the branches of your family tree are tangled. There's overlap and they cross over, and there's intermarriages in places that you don't expect and that you aren't ready to deal with. A true knot would be an endogamous population, and this lecture is not about an endogamous population. So this is what I would call a normal tree. This is what we expect a family tree to look like. So in that fourth generation, you can see each branch is a different color. We expect to have nice, distinct, different branches. And I don't know if this is normal or average, but I use the word normal for lack of another term for it. So this is a normal tree with distinct branches. An endogamous tree might look like this. So we have duplication of colors. There's, the top paternal couple also happens to be the ancestor at the very bottom in the mother's line. And then, so that of course then goes on into the next generation. We have duplication of ancestors. And in this tree, I've also included numbers. So if you were to look closely, you'd see not only do we have the same colors representing duplicate branches, but those branches are coming in from different relatives. So it's not just that, oh, this person's in here twice, the branches intermarried another way. So this tree has very few colors. This would be an example of endogamous, and this continues. This keeps going. If we trace this tree back, you would have very few colors, very few different branches, and they are mixed up in ways we don't expect them to be. So endogamy versus a knot. Endogamy means that you're going to have lots of duplicate ancestors. It occurs in a limited population over a very long time. Just a knot is not as severe a case. So there's fewer duplicate ancestors, and possibly they're only many generations back. Other populations intermarried with the group, or the population was very large, or the intermarriage was for a very limited number of generations. All of those things can mean you've got confusion between the branches of the tree, but it isn't as severe as endogamy. So all of these are things that we can see happening when we do research. So there is not a list of known populations that would be considered knotted but not endogamous. Southerners from the southeastern US is one example of this. This is why I'm familiar with it, because this is the population all of my ancestors are from. But it can happen anywhere in the world. I believe that something similar happens with a large number of Canadians, and I know we have a lot of people from Canada attending today. So I would love if you'll email me and let me know, particularly let me know if there's a way to describe a Canadian population, like I say Southerners. I don't have to say some people from the US. I believe this happens with Canadians and Southerners because this migration is similar. People came over around the same time. A particular group of them did not intermarry with all of the later immigrants that came in. And so you have that group intermarrying, but it's a very large group of people. And so that's why you don't reach that level of endogamy. That means that it's likely to possibly happen in Australia. I don't know if that's what's going to happen in New Zealand, but you can see, you could look for that pattern in what you know about your family. And this can also happen in small groups. So I found this happened when I was working on a client's research. In this particular case, she had German ancestors that came to Kansas. So this was in a fairly small area, and it wasn't a huge number of people that it affected. As far as I know, these Germans were not related back in Germany. My job was not to research the Germans, but I was dealing with other DNA, so I had to deal with it. But from what I could tell, they came from different places in Germany. So when they arrived in the US, then they began to intermarry. And they intermarried so much, it will make your head spin. However, it only happened for between about 3 and 5 generations. So this was a small closed population, but it didn't happen long enough for it to reach the level of endogamy. And after however many generations, that's when people started to move away from those parts of Kansas. Other people moved in. It happened into the early 20th century. And so just as you would have in the US with people moving around, that's when it started to change. So whether it's 3 or 5 generations depends on the individual family tree, and how severe it is depends on the individual family tree. But that's such a small group, you will discover that based on your own research. That's not something that somebody can say, oh, you're going to need to deal with this, unless they happen to have familiarity with that exact very specific thing. So this is something you have to kind of discover for yourself is an issue that you need to deal with. So many people have some tangling or knotting in their DNA tree. Depending on the severity of the knot and your goal for using DNA, it can cause different problems, different severities of problems with what you're trying to do. So I like to refer to this as a spectrum of interrelatedness. I want it to be clear, this is not you have a normal tree or endogamy, and you don't have normal knotted or endogamy. Knotted is anything between normal and endogamous. So there's all sorts of levels of how this can happen. And this is something I've figured out is going on from people talking to me and telling me about their situations, looking at other people's results, and hearing a lot of, I don't understand why I'm having this problem. And when I look at it, a lot of people, I look at their results and I go, it's because you're Southern, because that's my specialty. And so I can see that. But like I said, I saw the same kind of patterns when I did some research into Canadian families. So this happens, and it can have different levels on that spectrum of interrelatedness. So on the not so severe, the less interrelated end, it's going to cause confusion. On the end where you get towards endogamy, it can make DNA pretty much useless for identifying individual branches. You might be able to use DNA for something else or really do a lot of analysis, but something that someone with a normal distinct branches can easily do, the more tangled they are, the DNA is not helping you because it's knotted, it's tangled up and overlapping and mixed up. It's going to send you down the wrong branch. And it's going to at least waste your time. So none of us have enough time for genealogy. So that's a big deal for it to waste our time. So if you have this kind of knotted tree, should you use the advice for endogamy? Endogamy requires extreme caution. You have to be extra careful when you're dealing with that and do some other things. But that makes DNA analysis much harder. So you don't want to jump all the way to following the advice for endogamy, especially if you're on that end of the spectrum closer to having a normal tree with distinct branches. You will make your job harder. So you don't want to follow it just because it's going to make it harder. It's necessary because it is so hard when you get down to that other end, but don't make it harder if it's not necessary. So there's two roots of this problem. Your shared matches appear mixed up and can cause false leads. So the big thing I see people saying is, I don't understand my shared matches. I'm confused by my shared matches. So that's one root. And then you're also related to matches in multiple ways. And if those ways are unidentified, if you only know of one way and there's more than one way, or just you're assuming you're related in one way and there's multiple ways, even though they're all unidentified, it makes this problem worse. Dealing with it is more complicated. So I have what I refer to as 3 pitfalls dealing with shared matches if you have a knotted family tree. The shared matches can be false shared matches. The shared matches are not genetic, and then related to that is the leads provided are false. So I want to make sure everyone understands what false shared matches are. This can happen to anyone and you get warned about it, but you need to be aware of it. Just realize this is more common when you have a knotted tree because you've got those extra interrelated issues. It causes more of this problem. So this is what shared matching is supposed to work like. Here are the test taker and 2 of their matches. So what's supposed to happen is you share ancestor A between yourself and match 2, and you also share ancestor A between yourself and match 3, and matches 2 and 3 share ancestor A. That's what's supposed to happen. So when you don't know who the match is that you share between those 2 matches, but you do identify the shared match between the matches, you can then apply it. That's who you're looking for in your tree. And of course, that also means the shared ancestor could be someone farther back, A's ancestor. So now you know where you're looking. That's the way it should work. That's the purpose of saying use the shared matches. So false shared matches, we start out with the same 3 people, and they might share ancestor A between 1 and 2 again, but they share B between 1 and 3. And so we go, well, this isn't going to be a shared match group. They don't share the same ancestor. 2 and 3 share C. That's how this ended up being a shared match group. To be shared matches, you match one of them, you match the other of them, and they match each other. The shared matches does not guarantee anything else. So this is the situation that you get warned about with it being false shared matches. Like I said, it can happen to anyone, but it's more likely to happen when you have a knotted tree. So here you can see one of the problems. So if we don't know who is shared between 1 and 2 and 1 and 3, but we find a shared ancestor between 2 and 3, now we'd assume that C, the ancestor shared between 2 and 3, is our shared ancestor between these, because that's how shared matches are supposed to work. C is not your ancestor, though, so you'd be totally wasting your time. This is a false lead you're chasing down. You were looking for C in your tree because you didn't know who you shared with 2 and 3, and 2 and 3 had the shared ancestor C between them. So now the next case, the non-genetic shared matches, which I like to think of as false matches caused by multiple shared ancestors. So we have the same situation here. So say we don't know who is shared between match 3 and yourself. You share ancestor A between 2 and 2 and 3 share ancestor A. So once again, we'd assume that that unknown shared ancestor is A. So we'd assume A is shared between this group of shared matches. But when you're related to someone multiple ways, maybe you share A and B between 1 and 2, and you happen to share A, B, and C between 2 and 3, but you only share B between 1 and 3. B is the source of the DNA. So with ancestor C, who could obviously, I've said before, if that's not our ancestor, we could be spinning our wheels looking for them. Same situation here. But C could be your ancestor, but not the source of the shared DNA. So you're interrelated with this group, so you're related to all these people. But B is the source of the DNA in this particular shared match group, but you will not know that when you're starting. The problem you run into there is that if you use match 3 and look at their shared matches, you're looking for C in those trees for those people. That is where you're looking for say you already know about C. C is your ancestor. You're looking for C's ancestor. You want to make your tree go further back by finding the shared matches who share C's ancestor with you. You're looking for that clue there. But C is not the source of the DNA you share with 3. So you might find C in some of these shared matches with 3. I mean, if these people have intermarried, that's likely. But you're also going to be very confused because some of them are going to be sharing A probably, but most of them are going to share that DNA from B and B's lineage. So it's very confusing. You don't know what's going on and you're looking for the wrong thing in the tree. And the big deal is that B is the source of the DNA. This is about DNA, but in this case, you've also got other shared ancestors that are not the source of the DNA, which is where you get all the confusion. So this is a case of the family tree versus the DNA tree. Your family tree is all your genetic ancestors forever, all the way back, all those people that are your direct ancestors. Your DNA tree is only genetic ancestors who you inherited identifiable DNA from. So identifiable basically means that it's helpful to us. You might have some that is you inherited, but it's just too little to be helpful. And then there'll be some ancestors you didn't inherit any from. So there's only a subset of your family tree, the DNA tree, that is helpful with working with this situation. So one last pitfall to look at here. We share A, B, and C all the way around in our shared match group. But we got shared A DNA between 1 and 2 and shared B DNA between 1 and 3. So once again, we'll have the same kind of problems of we're going to be looking for the wrong thing when we branch out and use 2's shared matches or 3's shared matches looking for a solution because the DNA is not from all 3 of those ancestors. So the DNA tree is different from the family tree. Shared matches are full of pitfalls if you have a knotted tree. And having multiple shared ancestors, whether they're known or not, makes you have more types of pitfalls, and potentially there are more pitfalls as well. So you want to recognize these potential pitfalls and look out for them. There's also an unseen issue, which is unexpected intermarriage does not have to be in the test taker's tree to cause a problem. So that means you don't have to see it in your tree to see that there's a problem. Many people are having problems with this because it's intermarriages in the trees of their matches where the confusion is coming. And if you're on that end of the spectrum closer to normal distinct branches, this is even more likely to be it's in the matches rather than in your tree, which is more distinct. So you do not have to see this as pedigree collapse, duplicate ancestors in the tree for it to be a problem. So you can have this intermarriage happening in the matches trees, and it will still cause confusion in your shared matches because it involves your matches. So the symptoms and how to identify that this is the problem you're dealing with is first that you know you have cousin marriages or several cousin marriages in the test taker's tree. And then also what I've heard from a lot of Southerners is they're confused because their paternal matches are showing up to known maternal matches and vice versa. So that's a very common situation that will happen. But it does not have to be across paternal and maternal branches. It can be confusion between any branches. So if you've done a really good job on a branch and you've identified a lot of matches as belonging to that branch, and then you start working on another one and you're seeing the shared matches not make sense, you think they're supposed to belong to distinct branches, this might be the problem you're having. Most people miss that this is going on because it's beyond their known ancestors. There's a cousin marriage that's farther back in their pedigree, and they're not aware of it. Or the problem doesn't cross between maternal and paternal, so it's not as obvious. So you haven't discovered it yet, and so you're working along and you're making false assumptions. You're following those false leads with the shared matches because you don't see the problem. Literally, you're not seeing there's an issue. Everyone has some confusion with shared matches, but if you have a lot, you need to investigate and find a solution. So the number one solution for everyone is to build trees. So I have some advice if you're dealing with knots of where to focus on building trees. Flesh out the test taker's tree, put leaves on all those branches. A tree that goes with direct ancestors is deep. We want to also make it wide. So research the collaterals. Those are the people and branches that are interrelated to your direct ancestors, siblings, in-laws, and cousins. And don't just go to first cousins, keep it going. And make sure you're finding who the in-laws are. That is where people tend to start to see, oh, there's a surname I recognize. It's not in their tree, but they know it's somehow related to their tree. Collaterals are where the answers are to this problem. The next thing to do with building trees is build the trees of matches. Hopefully you all knew that was coming. If you're working on building the tree of the test taker and fleshing it out, then you build the trees and the matches. This can make it a lot easier because when you're trying to find those collaterals, you start then with the matches tree and it's easier to bring them together. There's fewer generations between there to then link them up. And don't rely on paper trees. Most of you are probably using software. You want to do that. But my big advice is keep one tree file for building trees to make it easy to link them together. If you have a knotted tree, you do not want to try and have, one file for this grandparent and then 3 more for each grandparent because you've got confusion and you don't know when it's going to show up. You want all of these people into one file. You can use MyHeritage's tree building software. You can use Legacy Family Tree. You can use whatever you want, but keep one. Don't have one at Ancestry and one at MyHeritage and then one somewhere else. You use those, you have one to connect to your results at each site, but where you're building the matches trees, have one so that you know where to put every match and so you can connect to them together when you figure out how they do connect. And particularly for those situations when you figure out the 3, 4, and 5 ways that they connect. So this was very quick. It's in the handout, and there's also a link in the handout that goes to a blog post that covers this in a lot more depth. I know if you aren't familiar with these concepts, this was a very fast covering of them. So the blog post goes into more detail about them, and there's actually 2 more blog posts related to it to come, because when I started breaking it down more and more, there was just more and more to tell you if you weren't familiar with these concepts already. So now we're going to talk about the MyHeritage DNA tools specifically. So I like to use the triangulation at MyHeritage DNA, and that's because it is so easy to use. And I have to tell you, when MyHeritage asked for webinar proposals, it took me about 30 seconds to come up with this one because I was just absolutely falling in love with the in-house tools at MyHeritage DNA for dealing with my knotted tree. So this is very much about dealing with the situation I'm describing and using MyHeritage's tools. I don't do it this way at any other site. This is specific to MyHeritage DNA because of the tools they provide. So if you don't know, this little icon on the far right of the shared match list shows that you've got a triangulation. So that's what you're looking for. And if it's not there, it's not a triangulated group. So what is triangulation? It's 3 or more people who share a segment of DNA and are shared matches with each other. So this doesn't guarantee a single common ancestor, just like the shared matches, but unlike the shared matches, you've added in that common piece of DNA. So where we had all those problems with the shared match groups that were possible, we've now reduce the chance of those a great deal by bringing in segments of DNA. Triangulation makes it statistically much more likely that 3 people share a common ancestor because they share a specific segment of DNA. And it helps you figure out who that is in the case, where we have multiple ancestors that are shared together. If you have a knotted tree, if you're from a population with a lot of people tested, you're going to have a lot of shared matches. If you have a knotted tree, you will have more shared matches than someone from the same group that does not have as many. So, I may have a lot more shared matches than you with my Southern ancestry because so many people in the US have tested. But if you're comparing, in another country, it may be that you just have more than other people in that country. So it's comparing apples to apples and not apples to oranges. But you will have more shared matches when you have this knotted tree because of all those false leads that we talked about. Shared matches provide lots of false leads. And triangulation can still provide false leads, but they're less likely. And the closer to endogamy you are, the more likely you're going to get a false lead when using triangulation. The biggest thing, and when it's not to the level of endogamy, is where you've applied the wrong shared ancestor. You're aware of one shared ancestor and not the second one, and the triangulation is for the second one. It's a false lead, but you still, in that case, would be having the same, you still have that DNA connection. It's just you haven't connected the segment to the correct ancestor. So this is using triangulation very on. When it's a simple to use tool, it can help you avoid some of those problems when using shared matches. It's about clues, not answers. So there's 2 basic steps. Identified shared ancestors with your MyHeritage DNA matches. So that means building lots and lots of trees, and so you're focusing on building the trees first. For everyone, I recommend focusing on building trees before you start using other tools. Building trees is a DNA tool. Start with the building trees. Once you've identified a shared ancestor, you look at the triangulated shared matches to see if you find the same shared ancestor. People that have that normal tree without the mix-up between the branches would do this with their shared matches. So this is the only difference is, you build the trees, you find a shared ancestor, you go look at the shared matches. But if you've got this knotted tree, you might want to look at those triangulated matches first. And in this, we're looking to see, does this make sense? Do these other matches also share the same known ancestor, or am I finding different shared ancestors, indicating that there may be another shared ancestor, or that you have one of those false leads that's a coincidental false lead. It's not because you have shared ancestors between that group. So if you click on the triangulation icon on MyHeritage DNA, you get your chromosome map, and that is not what we're using at this stage. I just wanted you guys to see what you will get if you click on that. You want to still stick with the trees and building trees. We've just now decided where to focus based on those triangulation groups. And you can still use those shared matches. This is just a way to start to make sense and not get bogged down in the shared matches. It can help avoid false lead when you're likely to have multiple shared ancestors. So here was our false shared matches. This group would not triangulate. That's why we're using it, is it goes around these that we can't know that this is a problem until we've just done so much work and wasted so much time looking for an ancestor that's not ours or is not shared between particular matches. Having a false triangulation group is more likely in an endogamous population, so you want to know that's who you come from versus just having a knotted tree. And when the segment sizes are very small, so do not use those small segments initially with the triangulation. Those can lead you through a whole different set of pitfalls that if this is the stage you're at, you are not ready to deal with those. So check the segment sizes for clues to problems. So some general triangulation hints and tips. Triangulation is not the first tool you'll use. It's only a good choice when it's so easy, like at MyHeritage DNA, or when you've worked through other tools and then it's the appropriate time to use it. But you will start by building trees and looking for shared matches. It's more beneficial early on for the knotted tree. And it is not a magic bullet. You want to start with those large segments because the small ones can lead you to a different set of pitfalls. Look out for groups of only 3, but do consider you can bring in and manually triangulate with segment data from different sites. So you may have, a group of 3 at MyHeritage, but you can grow it to a group of 10 when you bring in GEDmatch and Family Tree DNA. It's not uncommon to have a triangulation group where all 3 people share one segment, but they share multiple ancestors. It's the family tree versus the DNA tree again. It's really important in this situation to be very aware of this because you're not sure when you're done finding shared ancestors. You check the segment sizes for this. That's the most important thing to try to figure out if there's a problem. And it's not perfect, but that learning to use segment sizes and total shared centimorgans is the way to avoid some of the problems. So triangulation is easy to use at MyHeritage, just as easy as shared matches. It's a way for people with multiple shared ancestors to avoid the problems of just using shared matches. And you only focus on triangulation with the closer matches when you're starting out. It can be a way to expand a group of matches to focus on, but don't get carried away with it. You're still using those other tools that you have in your arsenal. You're still using shared matches. You're still building trees. It's just a way to focus. So the handout goes into this in a little bit more detail and kind of a more process oriented, because I know this is a lot to wrap your head around. But if you're already familiar with this idea, I want to give you some information on the next things I do with MyHeritage DNA's tools. And basically that's taking triangulation further. So I add in chromosome mapping by mapping the shared segments. And sometimes I bulk upload a whole lot of them, and sometimes I do one at a time. So there's different ways to do this. DNAPainter is probably the most popular way to do this right now. And the thing that is so helpful is you can slowly add segments and you can keep easy to access notes. You can use whatever way you want to map, but when you've got these interrelated lines, easy to access notes are really important because you want to check back and see, oh, I had confusion. I wasn't sure if this segment belonged to either of these possible ancestors. And so you want to know that quickly. It's important to be able to get that information up. So it's great that that's there. When you have just a few minutes, you're not having to go hunt up your notes and pull up the website and pull up MyHeritage's website. You've got, you need MyHeritage and DNAPainter, and your notes will be there for you to see. The purpose of this mapping is not to map the complete chromosome. So a lot of people like to do that. It's fun to see the pretty picture it makes. That's not the goal here. The goal is not to map to an exact ancestor. We're dealing with this knotted tree and we want to untangle the branches. So one thing it can do is identify pile-up regions, which is a pitfall when focusing on those triangulated matches. So triangulated matches helped us fight the pitfalls of shared matching. Chromosome mapping can help us fight the pitfalls of focusing on triangulated matches. So a pileup is an area where you share an excessive number of matches and they all have a nearly identical segment, and you will run into these when you focus on triangulated matches. This can indicate the shared ancestor is too far back for you to identify. And I have a section at the end, I don't know if we're going to have time for, that'll show a picture of this. Lots of times when people talk about pileups, they're talking about really small segments, the size I'm not telling you to deal with. I found one right away doing this that is definitely a segment size that I would normally work with, but I suspect it's going to turn into, when I start adding in the smaller segment size, it's going to turn into a major pileup region, which may mean that those segments of a size I'm used to working with might actually come from a more distant ancestor than I expect. And I'm basing this partly on the research I know about this, the traditional research into this family, that the segments of that size, I don't think I can connect those people's trees to my tree and the number of generations I would expect to do that. It's going to be more traditional research than I can deal with right now. I don't have the resources and the time to deal with it. So identifying this says, set this project aside and work on something else. So that's a better use of your time. You're not spinning your wheels, going down false leads, or just doing work that you're not going to be able to complete. That leaves you frustrated and out of time. So when you add chromosome mapping, you can also use inferred matching. And to me, this is getting close to being the magic bullet for Southern DNA. I can't speak for other places in the world, but this has made a huge difference for me. So it increases the number of segments you can map to a side, the maternal side or the paternal side, but possibly also to a branch or a specific ancestor. So we talked about one of the symptoms is that you have confusion with your matches because the maternal are matching the paternal and vice versa. So if you can figure out if they're maternal or paternal, you can knock out all the shared ancestors that it could be, but have to be on that side. So that on its own can be really helpful. If you can get it to a branch, it's even better. And maybe your confusion's just between a branch, so maternal and paternal is not that helpful. And then obviously we all want to get that segment to a specific ancestor. So inferred matching is based on the fact that you have two halves to a chromosome, maternal and paternal. Each segment has to be either maternal or paternal. It can't be both. If you can determine some segment side, maternal or paternal, you can then also infer those who don't match but are at the same location. Those must be on the other side. So this is like binary. You know, it's 1 or 0, 2, 3, 4, whatever are not a choice. It has to be 1 or 0. So if it's not 1, it must be 0. And if it's not 0, it must be 1. That's why this works, is that you narrow it down to those choices. Once you identify some segments as coming from an ancestor or couple, this can really start to untangle your DNA tree. So obviously, you know, once you figure out if it's maternal or paternal, if you don't have mixed up branches, it's not that big of a deal. But when we do, we're sometimes going, well, I'm not sure if this segment is coming from, you know, my Patterson branch or if it's coming from the Taylor branch, because those are both in my family, but they shouldn't be intermarrying at this point. Well, this inferred matching can help you figure out, oh, this segment is one or the other based on what you've already determined with that chromosome map. So it helps you, even though those are both options based on who the shared matches are, it helps you start to identify those segments, and then you know other people that match on that segment where they will belong. And so that starts to help when you start to narrow it down. And like I said, when you've got the branches confused, it really makes a huge difference. The closer to endogamy you are, the more difficult this is because there are just so many choices. It's much harder to narrow it down. If you're not overly interrelated, it can make a huge amount of difference because you may still have a lot of confusion and it may not be any easier to sort it out, but this can be quite an easy way to do it. This is from DNAPainter and it comes with a key, and so I've labeled some of these segments. Now the ones that are gray, I don't know who they belong to, and there's also an entire section above here I didn't even cut into this screen that is people I haven't even determined if they're paternal or maternal. But this was a good example to kind of show you how you can sort of infer these different things. This is one chromosome from DNAPainter, and I didn't include the unknown. There's a whole bunch of segments that I don't know if they're paternal or maternal yet, but this was a good example to show you how you can do this inferred matching and what it takes. So these are the segments that I've identified as paternal, and some of them I've mapped to couples. And then here are the maternal ones, same thing. And I also used some groups. So here are paternal cousins. So I was able to get first cousins and some second cousins tested. And I grouped those into cousins for the correct side on here because those are the people I use to determine if they're paternal or maternal. But I don't know yet. They're not helpful to figure out any farther. I will have to determine based on other matches that are more distant which segments of the cousins belong to which ancestor. I just know which side from these cousins. So that's the place that it starts. And that's why this one was helpful. I had both maternal and paternal at this same segment. So this was a segment that I could really focus on and I could really figure out who belonged to this one. As I started to do that, down here on the maternal side, I discovered this was one of the peace ancestors. And so everybody in that segment should be pieces. They should not be Millers. The green that's lower down is the Miller family. If they are a maternal match at that segment, they cannot be Millers unless I've made a mistake, because this segment is from the piece family. It cannot also be from the Miller family. If it's not from someone in that piece branch somewhere along the way, it must be a paternal match. Those are your options. So that allowed me to figure that out with the maternal side. And that can be helpful because I can say these matches are not related to the piece side. And so I can mark those as likely paternal matches then, because they cannot belong to that piece segment. And so I can go ahead and put them up in the paternal section. But then I did have some that I could match in the paternal section to the Patterson-Townsend couple and the Williams-Crittenden couple. So here are all the others, and they don't belong to any of them. Now, I do have the cousin marriage in my family that is Ledford Patterson, and that Patterson is the sister of the Patterson and the Patterson-Townsend couple. So in this case, I'm not crossing out the Patterson option, but it is not going to be a Ledford. That is a different branch of the tree. However, this went far enough, actually, that I could determine this was not from the Townsend side. The Williams-Crittenden line is the ancestors of the Patterson. So this is going to be a Williams segment here. So I was able to figure that out because I don't have other options. That's how inferred matching works. That's how your inheritance on your chromosome works. So at this segment, they have to either come from that Williams branch, and I don't know exactly which ancestor it comes from yet. I just know it's somewhere in that Williams branch, or it has to come from that piece family somewhere in that piece branch. And I pray they don't interlap farther back, because they do both come from South Carolina at some point. So now any match identified as paternal on this chromosome in this location should be from the Williams branch. So I can focus on the most likely branches in the matches tree first based on this. So all of these gray ones that I don't know where they come from, I'm looking for a connection into that Williams branch. And I'm hoping I find the surname Williams, because that's a brick wall. The Williams-Crittenden couple is a brick wall. And so hopefully these smaller segments would help me break that brick wall. But they may just end up falling into it. And having more matches just strengthens your analysis and gives you more to work with when you do bring in some smaller segments. So I want to quickly talk about the problem tool if you have a knotted tree. This is a big warning if you have a knotted tree. This is part of the reason I go through all the explanation of what a knotted tree is. Be careful with those auto-cluster tools. So auto-cluster tools work phenomenally for those normal tests with those nice distinct branches. However, most people are confused about how to use them, how to use the results from it. So it can be a problem for everybody, but they do, once you understand how to use them, they work great when you have distinct branches. The more knotted your tree, though, it will create false leads. It's not a good early choice if you have this knotted tree. It can be a fantastic early choice when you don't, but it is not a good early choice for a knotted tree. If you have some normal branches, the auto-cluster tool can help you sort out the branches some, so you could focus on doing what you can with your normal branches or doing what you can with your knotted branches, so that you can separate them. This is that issue of where on that spectrum of interrelatedness, and for each branch, what is it? So that applies to this, is you can use it, but you can have false leads if it's a knotted tree. It's because the clustering for this is based on shared matches. So shared matches cause lots of false leads. And so those false leads can be passed to the auto-cluster tool. The more interrelated the branches, the more likely that you'll have false leads because of it. Skip the small clusters with them. This is actually my pet peeve with auto-cluster tools, is I consider they over-cluster. I mean, that's the whole point of it. But with an interrelated tree, it's hard to work with all of those small ones. It can help you focus and choose projects, but the small clusters aren't as helpful. They can result in false leads because you don't have enough data, basically, to figure out what's most likely. You've narrowed it down too much, and if one of those is a false lead, it can throw the whole cluster off. And when you have a cluster of two, which they provide, that's just a group of shared matches. You could look at just your shared matches for that. If you use auto-clusters, understand how it works and know the situation in the test taker's tree. Like I said, you can separate out branches even if it's just a partial knotted tree. So that is possible. And then pay attention to the superclusters. Most of the tools will show you as superclusters, usually with a box around clusters. And that the superclusters can overcome some of those problems because that is a group that may relate to a branch. So the individual clusters might have some false leads and confusion, but the supercluster might relate to a branch. So the MyHeritage DNA Auto-Cluster output, though, is actually a really good shortcut to use. The biggest problem with it is you don't have control over which matches are put into that Auto-Cluster report. So you can't use it for everything, but it's a different way to look at your results and focus differently. And I find it's a faster way to check trees. So you're always reviewing trees for shared ancestors and building trees to find shared ancestor. So there's a table, and you can scroll and see the tree sizes for those. And then there is a hyperlink directly to the tree. So there would be your pretty chart at the top. And if you scroll down, there's the table. This is actually a screenshot of the whole thing. This is not two different screenshots. This is what it would look like if you scroll down past the pretty picture. And you download that HTML file, so you don't have to have an internet connection to use it. You do have to have an internet connection, clearly, to click on the links for the trees. And so the one thing I don't like is these do keep them sorted by the clusters. But you can then sort by the centimorgans within the clusters, largest segment, number of segments, in common with. You can sort them by the cluster number and also just pull up select clusters. So you can look at one, which I think will also pull up 19, 17, everything with a 1 in it. But then you have that column that tells you how many people are in the tree, if there's a tree, with the link to it. It does not tell you whether or not the tree is public or private, but a lot of the ones on MyHeritage are public if they're there. So I'm not going to spend my time clicking through on all the ones that say there's one person in the tree. That's the same thing as no tree. And you will click on these and there'll be, 1,000 people in it, but none of them are connected to the match. So it doesn't tell you that, but it's still faster to do this and see there's something even there than the number of clicks it takes to go through this in the shared match list on MyHeritage. The big time saver is having the notes over to the side. And I've blurred them on here for privacy purposes, but the notes are there and you can read them. This is done by entering notes directly on MyHeritage. That is probably the number one most overlooked on-site tool for every site. The on-site note field can save you so much time by making it quick to access the notes. And then also, whenever you get an output like this, because you can get this output for different sites from different apps, to be able to review a list of notes. So here, this particular cluster I know relates to the Ledford potential pileup. And if I look at these notes, it tells me that all these people have Ledfords identified in their tree, and I don't see any other potential connections to my family in those. So that makes it much faster to look at that. So the new tool that DNAPainter has come out with is the Cluster Auto Painter. So you can now combine the MyHeritage Auto-Cluster tool with this new DNAPainter tool, and essentially it puts everything we just talked about together into another way to do all of this a little faster, a little easier. There's still more steps after it, but for this phase of DNA analysis, it really speeds it up. And this was something I discovered only a few weeks ago. I was halfway through creating this webinar when I discovered this. So I'm very glad we have a little bit of time to talk about it, because it really did take everything I was already doing and kind of put it all together in a slightly simpler to deal with format. So the auto cluster can still lead you down the wrong branch, but the Cluster Auto Painter allows you to focus on a cluster at a time, so it keeps the clusters when it maps them for you. And it gives you another option besides triangulation. So you can now use both of those if you want. You can also go ahead and use the CAP or CAP tool, whichever way it's being referred to, and also do triangulation and switch back and forth between the two ways to try to get different views, or sometimes your brain just gets tired and you just need to look at it differently. So you can use that table and the HTML output to much more quickly review trees, because now you're looking at the chromosome map and seeing what you see in the chromosome map, what that leads you to. This is a faster way to pull up a tree when you suddenly go, oh, here's a match that I haven't looked at yet. Let me look at it. So like I said, it brings all of this together in a slightly easier to use format. It's fast to find it because you already know what cluster it's associated with. The thing that I really like is the DNAPainter, half of it allows you to specify the segment size. So you can use this to start with larger segments. So you can import the larger segments clustered to kind of give you a double focus. It allows you to focus on each cluster at a time, but by starting with just the larger segments. So you want to look for those shared ancestors. This is when it's really helpful to get to that inferred matching, starting with those large segments. Here's a clue. Maybe this cluster, these people will all have the same shared ancestor, or maybe you can at least determine a branch or narrow it down to maternal or paternal, whatever's appropriate for your situation. And then you can make those notes at DNAPainter, and you can create new groups. You can easily move people between groups. You can then, I put this into, this opens a separate file, and so you do really want to do these steps in a separate DNAPainter file. You can then move individual segments to a different chromosome mapping within DNAPainter once you find one you're interested in. So that's a way you don't have to go back to MyHeritage to copy that segment data. You can put that together. And of course, you can also bring in, if you wanted to, you could bring in information from other sites into your output from the CAP tool. And that was the triangulation inferred matching. This is a great way to determine if your clusters appear to be accurate or not. It doesn't matter which. Figuring out either is helpful. So this is a map I did with this, and here's where I was talking about this potential pileup for cluster 1. This would not qualify as a pileup, all these coral colored pink, red. I'm not sure what color you guys are seeing exactly, but in the middle of the screen here, this group of them would not really qualify as a pileup per se. But like I said, when I was looking at these, I was finding all of the Ledford surnames. I kept finding multiple Ledford, nearly all of these people. I found the Ledford surname and no one else that would be the connection. But I've done enough DNA painting. I know segments of this size should be closer related than those people possibly can be. They have to be farther back in the tree. So this, there's an extra large segment of DNA that I've inherited here, or something unusual has happened in the inheritance of this DNA, so that this is not a slam dunk project that I'm going to work on and solve by the end of the week, because I have all these Ledford matches, because the traditional research is just too much to connect them up. I now know that very likely the story of the 3 Ledford brothers that came to North Carolina does appear to be true in this case. You know, I've got Georgia Ledfords. These are Kentucky Ledfords. Allegedly, they all came from these North Carolina Ledfords. Well, they're starting to connect with DNA. Don't know how, but they are having shared DNA. So it's not a waste of my time to consider all the potential Ledford leads, but I don't want to put all my effort into this, because I don't think I can do the traditional research to actually make the connection and find the actual lineage at this time. So it's choosing how I'm going to spend my time. So I want to recap now. So 3 steps for knotted trees is build the test taker's tree as deep and wide as possible. Determine how interrelated the tree is, and remember it can be different in different branches. And build matches trees and do the same with them, especially when you have an idea which branch you share in. Do you see cousin marriages in those branches? Do you just see a lot of cousin marriages in all of their branches? It means it's going to be more trouble for you. So that's good to be aware of that. Then you can bring in the MyHeritage DNA tools. You always are doing the tree building first, but then you can bring in triangulated matches, starting with the match with a known shared ancestor. So the whole point is to start with one that has that known shared ancestor, and that's to help you focus. I only do this at MyHeritage DNA because the triangulation is so easy. I really want to make that clear. I would not do this at GEDmatch. You can triangulate there. It just doesn't work out the same. I do some different steps because they've got a lot of different tools there. So this is how I do this with the MyHeritage DNA matches. And I have to be honest, I'm making like amazing progress all of a sudden doing this. It's not just the MyHeritage DNA, it's the 4 years of intensely building trees for matches. I now have so many matches trees built. I'm starting to find connections much faster because I'm only having to hang 2 generations onto an existing tree in lots of cases. And even if I have to put 3 or 4 generations on, it's a lot better than 7 or 8. So that's the backbone for it, is all that tree building. But then using this process just really can make a huge difference. Use that provided note field. It can save you so much time. Then add in DNAPainter, map those segments and add inferred matching, add segments from other sites, and don't forget to go back and add notes at MyHeritage DNA based on what you find. Make notes about the collaterals, the interrelatedness there. So don't just, leave it be, especially don't leave it with your own old notes that say, no tree, after you've built this amazing tree that you're like, oh, there's the connection. This solves 6 different problems for me now that I see how this family works. Be careful using the auto-clustering, and that applies to any site because it's based on the shared matching. If you have confusion in the shared matches, it can pass to auto-clustering. And then you can use that DNAPainter CAP tool, the Cluster Auto Painter, to help you focus and determine if you want to use auto-clustering, if it appears helpful or misleading for you. So the final tip is eventually you have to focus. This means not just looking at a list of matches and randomly doing something. A lot of times we're just like, you start at the top and you just do whatever, and you go off here and do something else, and it's just random. Every time you look at it, you don't have any plan or anything. You need that plan and the methodology, what tools you'll use. Also, eventually you need to focus on something lineage related. It can be a branch, it can be a specific person, but combining those two really makes a big difference. A lot of people focus on using a tool or focus on an ancestor, but they don't have a methodology. They tend to do one or the other. So eventually making that focus of both those, you need an overview to start. But once you're past that stage, you will make so much more progress when you focus. You don't have to stay focused for months on one project. You can switch. You could switch projects every time you sit down to work, but you will get more done if you sit down and have a methodology and a specific thing you are working on each time. So just a reminder, the review is in a blog post about the shared matching, the pitfalls, and the knotted trees. So that is in the handout. And that is it for now.
Wow, Jennifer, thank you so much. Loads.
Does your head hurt?
A little bit.
Yeah, I know.
But yeah, a lot of people are saying that they're going to rewatch the webinar. Murray is saying great webinar. So I've got loads of questions here. Let me see though. Let me just ask you one question before I do the announcement. So Elizabeth is asking. There's so many questions coming through. My question keeps moving. Where's here it is. Okay. She's saying, you said not to build the matches trees on paper, but where do you build your matches tree? Are you doing it in your own genealogy database or a separate standalone tree? What are you doing?
I do a totally separate file because it's going to be a huge mess. So I build mine on Ancestry because I started with my Ancestry DNA matches. So I have a separate tree on Ancestry that is totally private. Do not make this thing public because you don't know what kind of mess is going to end up in there. But I have a private tree that is called DNA Matchwork, and it is nothing but matches trees, and it is the matches from any site, anywhere.
Okay. All right, so that's a good start. Let me take the controls back. I'll do the announcements real quick, and then we'll get to these many, many questions. All right, so just get put the questions away for now. All right, our next MyHeritage webinar is coming up on February 11th. Tune up your family tree with MyHeritage Consistency Checker by James Tanner. So that should be very good. James Tanner does great stuff. So be sure to be here on February 11th to check that out. And then, oh, hey, we're already at our door prizes. So our first door prize is the 1-year MyHeritage Complete Plan. And so there is two sides to this. There's the Premium Plus Family Site subscription, which allows you to build an unlimited size tree and all that goes with it for building your tree. And then there's the data subscription side, which is the access to all the historical records. And so that gives you unlimited access to 11 billion historical records. And, you know, MyHeritage has records from all around the world. So no matter where your ancestors come from, hopefully you'll find records for that country or countries. So this first door prize is the 1-year MyHeritage Complete Plan. Everyone who is here right now is eligible to win this. I just have to select one person from our audience, and that prize is going to go to our attendee, Brian Bonham. So congratulations, Brian. You have won yourself a 1-year MyHeritage Complete Plan. Now let's move on to our second door prize. This is the MyHeritage DNA test kit. And someone was just asking in the chat, I'm not going to go look up your name right now or else I'll just get all confused, about whether you could use these tools today that Jennifer's talking about without having your DNA. He said he had a tree, but he didn't have his DNA tested. So using these Auto-Cluster tools and stuff, you really have to have your DNA at MyHeritage, whether you upload it, whether you transfer it, or whether you use the box here and actually provide a saliva sample and send it in. All right, so I'm going to select somebody here today to win this MyHeritage DNA test. And if you've already tested yourself, of course, you know, give the kit to one of your relatives. It makes it so much easier to sort your DNA matches when you test your relatives. All right. And the winner for this is Sunny Rattan. So congratulations, Sunny. We've got a DNA test coming your way. So for both Brian and Sunny, you will be getting an email directly from MyHeritage with instructions for how you're going to win your door prizes. All right, let's get back to Jennifer with the questions. And I got to pull these questions back up again. All right, so one of the questions I want to tackle right away, because so many people are asking this question, is what do you call a small segment?
I usually, when I'm doing the steps I outlined, I usually don't look below 30 centimorgans. I often have a cutoff at 40. Now, as you work on a specific focused project, that number gets smaller and smaller and smaller. But you also have to take into consideration your DNA, what you are looking at. I do a different technique for Ancestry DNA, and so it involves transferring the results over to Excel, and so I have to make a cutoff because otherwise I crash my computer. For other Southerners, my cutoff is normally 40 centimorgans on that. I've had to cut it off at 75 because they have so many matches. So small depends on the task you're doing and what you have to choose from. I mean, you may have to go down to 20. I would not be going below 12 until you are pretty far along with analysis, no matter what. But small can be 50 centimorgans for some people because they have so many matches with larger segments.
Wow, so that's so interesting. So I guess it's really going to depend on the person, because like for myself, I'd have to go down to 15 to start getting some serious matches. 75s, I'd have like 5. You know, I don't have a lot, so.
And that's why it's really hard to talk about. That's why I say small segment and I don't give you a number. Like I said, for Southern, it is not uncommon to make small is a much larger number because there's so many people tested. You will have so many more matches. The fewer matches you have, the lower your numbers are going to be. But you want to stay above 12 really when you're doing this initial work because things start to get sketchy below that. Like I said, when you start focusing, it's a whole nother story. I've worked with much smaller segments when I've really narrowed down and I've gotten a really tight group of matches to work with. Other times they'll say, oh, don't use a segment that small. It might be a false match. But when you have enough other reasons to use it, you can use it. It's just you don't use it initially. So it's a personal decision, and you have to figure it out from working with your results.
Okay. And then the follow-up question to that, of course, was what's the recommended size of CMs for triangulation? Mary was asking that. Jane was asking that. A whole bunch of people were asking.
It's still very much the same thing. That is, you really want to get maybe 5 of them of a decent size. Like, you hope they're over 20. If you can get like 5 of them, and the first thing to do is, if you can only get 5 of them, that the triangulated segment or the total CMs were over 20 centimorgans, because you might pull in one that's smaller because the total is more. You might want to focus on those 5, contact them for more information, build their trees, and so you would focus on that group, which would be different than if you could keep that number up at like 40 centimorgans. Your exact steps would be different if you had 100 people that you could choose from at a higher number. So, you want to focus on this and decide what to do. And so, like I said, it's a shifting number depending on what you're looking at. And remember, I said with the triangulation, you're starting with someone who you've identified a shared match with. How interested are you in that person? If this is like the reason you're doing this, take it smaller and, spend the time on that project. If you want to focus on that, you can use a smaller number. If you've just picked one because they're all of equal interest to you, if you're only having small sizes, you might want to look at another one with a larger segment sizes to decide. So it's a hard number to give you an exact number for. Also, when you watch other webinars or information, if what I'm describing is drastically different and what they're describing is more similar to what you experience, use that advice. That's why I started doing this. Is what I was hearing described was not the situation I was experiencing with all Southern ancestry. So adapt for your situation.
All right, we got loads of questions here that we've got to try and get through, so everybody will be happy. Let's see. Zoe, my son's name is Joey. Zoe wants to know. She's on the same page with you, but she wants to know, is there a way to download the triangulations? I know you can do that at GEDmatch. Is there any way that you can do that at MyHeritage or any other site?
I am not positive off the top of my head, because MyHeritage downloads stuff so differently that I know some of theirs, you click one place for this and another place for that. I don't think so, because I don't think you can get just a list of the triangulations.
Yeah, I know that you can download your entire match list at MyHeritage, but I haven't seen a way to download just triangulation.
You can get a shared match list. I know that.
Yeah,
so
shared match list.
You can narrow it. Yeah. Well, you can do it. You can get all of them. Then you can get just shared with one ancestor, but I don't think you can then break it down to just the triangulations. So.
Yeah, because I mean, it is a spreadsheet. You can sort it, but it doesn't quite get there. All right. Well, so Zoe, that's the best we can do today. Cindy wants to know, what happens when one parent comes from an endogamous population and the other parent doesn't?
First, you pray that there is no overlap at all. And as long as they're separate, you can treat them separately. The tool should work where you will have your endogamous population, which is a hot mess that you don't even necessarily want to look at. And then you can do all of this just on the other half. If there's overlap, you're going to have to treat the whole thing as endogamous until you can separate it out somehow. And I've given this lecture several times today to myself, and so I can't remember if I actually said, I like the clustering tool at GEDmatch because you can cluster a subset. So that is an option for that if the MyHeritage Auto-Cluster is not clearly endogamous clusters, non-endogamous clusters. So there are ways to kind of separate it out. And then from those clusters, you can decide who to work on. You can use that to help you focus. You don't have to work with the clusters in the list there. That can just be a way to pick a focus.
All right. Barbara wants to know, is inferred matching the same as inductive mapping? Inferred matching, so. Inductive mapping. Yeah. That's the same?
I had to keep looking up because I kept calling it all sorts of different things. So it's possible I've put the wrong name in somewhere, or it's getting called by multiple names. So,
Oh, and so while we're talking about endogamy, Debbie wants to know what is the exact definition of endogamous. Not
well, it
everyone's
depends on,
familiar with that.
yeah, it depends on where you look it up. I always go with the definition. It is, intermarriages within a closed community over a long time. The problem with that definition is that's what I just described as a knotted tree. But I believe, like, if you Google it and you get a non-genetic genealogy definition, that is one of the definitions that comes up. So in genetic genealogy, it is either such a small population over such a long time, there's a relationship there between how many people are interrelating and how long it lasts for it to count as endogamous. And basically, it just means that you have so many duplicate ancestors throughout your tree. And so that's the thing that I think you need to look for is how many duplicate ancestors are you seeing in that tree? And so you will have a lot of them if it's endogamy. If it's just a knotted tree, at some point you might have a lot, but probably not. Like I said, in that example of the Germans in Kansas, that is exactly like endogamy, except it doesn't last long enough. It doesn't keep going. Those trees then start to separate into distinct branches when you go farther back. So it's pedigree collapse in the sense of you don't have enough ancestors, but it is an extreme, extreme case.
All right, Chris and Karen want to know what segment size do you recommend to start with for using the CAP?
Whatever
CAP.
whatever you decide to use for other things. Like I use 40 for a lot of things. And then if you don't have enough matches or you have too many, go in and change it. Because you will get a download of your MyHeritage Auto-Cluster. If you don't like your CAP results, delete it, do it again and change it.
Okay. And I think this is related because it was at the same time. Dale is asking, so I don't have to go to DNAPainter anymore. I can access it through MyHeritage. I think he's talking about the CAP stuff. Dale, please correct me if I'm wrong because it's just out of context for me now since we're not live in the webinar. Do you understand what he's saying?
Yeah, and I don't know. Like I said, I had just found it a few days ago. I used it.
But that's at MyHeritage or at DNAPainter?
No, I was using it at
Okay.
DNAPainter, and you access your Auto-Cluster result from MyHeritage. But I don't know how many days it's been since I accessed the Auto-Cluster because that's where it would appear. So I may not have looked at that screen. So I am not sure. The last time I looked, no. But things change fast.
Okay. All right. I've got more questions here. Let's see. Mary wants to know, would you consider Ireland an endogamous population?
I don't know. All of my ancestors are from Georgia.
Okay.
But I have seen, I saw this a lot in Welsh families in Canada. So I'm guessing you will probably have populations within Ireland. Just being Irish, I don't know if that's enough, but you will certainly have that within populations in Ireland.
All right, I'm going to give a little tease here to Mary and everyone, so please forgive me. But very soon on Legacy, you'll be able to answer that question. That's all I'm going to say because I don't know that I have permission to say anything more at the moment. All right. Okay. Let's see here. So Tara says, my parents are from the island of Cyprus, where a lot of people seem to marry their extended cousins and such. Would you consider this endogamous or knotted or both?
If you are endogamous, you are definitely knotted. And that most likely is because that is a small enough population. If it's going on long enough, if they're not intermarrying with other people, if somebody doesn't come to the island to bring in fresh blood, it's going to end up being endogamy. Like I said, I don't know that one specifically. Endogamy is not my specialty. That's exactly why I know about dealing with this knotted trees is because I'm like, I'm not from an endogamous population. This is not helping, but neither is this, other advice over here. So I definitely am not familiar with all of the endogamous populations that are out there, but there's a lot more information about it out there than the in between.
So, Terrace, I think there's an opportunity here for you to become an expert on this kind of DNA situation with Cyprus. Maybe find some other people from Cyprus who've had their DNA tested and put together a working group and see as a group if you can start to sort all this stuff out. That would be really helpful. And then go to the genetic genealogy tips and techniques group and share it so we can all learn.
Yes.
That would be super.
I only want to talk about Southerners, but I know there's lots of people in the world having this problem. So if everybody takes their own, that would be fantastic.
Yeah, there's lots of room, really, for people to become experts for particular countries because, you know, the experts that we have, they spend so much time on their own genealogy and then trying to help other people. They can't possibly cover everything in the world. So there's a real opportunity for people to step in and start exploring their own roots more at that level. So
you can only work with the results that you have access to. So I begged for a bunch of Southerners to give me their results to see more. I don't have time to beg for just like every random group that I can find out there. It's just not possible.
Oh, it's hard enough just doing our own DNA, never mind anybody else's. All right. Catherine wants to know, would the false shared matches show up in lines that the knots are from the 1700s or 1800s?
Yes.
Yeah, I think so too. I think that's all of mine are early 1800s. So
that's actually when you have one of the like biggest problems because that is getting so far back. It's not tipping you off. It's like it's those little hidden pearls in there that are not really represented in your tree. They'll be in your tree once you build it far enough.
Yeah, and that's
confusing the DNA.
That's the problem because at this point we don't have the documentation anymore. Like my problems are in Pennsylvania, and you know, it's a big old ripe mess trying to, you know, find documentation for it. You just can't. So you know the people are connected somehow, but you just can't find the records to figure it out.
Yeah, and that's exactly those are one of the most confusing problems in there, and so it's the biggest issue is how much of that do you have? Those little ones are going to cause a problem for everyone that has them, but some people just have a few of those. They have a lot of distinct lines, and some people have a lot of those, and all of those little 1700s, you know, they all are from Virginia. Yay!
Let's see here. Miriam says, in inductive mapping, do the chromosome match exactly in each family, or is there overlap? If there is overlap, how do you figure out which is which? And that, I guess that would be a common problem for everybody.
Say that again.
So she's saying in inductive mapping, do the chromosomes match exactly in each family? I guess she's maybe saying paternal side, maternal side, or is there overlap? So she's saying if there's overlap, how do you figure out, you know, which side or which family that the chromosomes belong to?
The big thing is, to first separate it into those paternal and maternal side. And so get to there. And then I basically think of it as a segment is representing a branch. Eventually, what we would like to get to is on all of those big segments, you will figure out each piece of that, who that belongs to. And so, you know, those big ones come from closer relatives. So those are, you know, going to be related. So, you know, you're going to have 4 great-great-grandparents making up that segment once you can figure out how it's related. So that's where you get some of that overlap happening, is part of that segment is where it's not shared with somebody who has shared ancestors farther back. But that's why I like starting with branches instead of going for, that's why I do the couples, is it's like a branch. It could be any of their ancestors. Because you don't know yet, that whole segment is not going to stay a Williams segment. It's going to come from pieces that intermarried. It may not be a Williams, you know, with that particular surname at all. It's coming from the branch that intermarried into that family. And so it's going to get broken down. And so that's why you'll get some of that overlap. So your segments are not going to match up exactly, except where you have an exact segment from the same ancestor. Then you'll have other people where it is combined somewhere else in the family. So it makes a mess. And that's why I like the branches for that. It's very confusing to say this comes from this ancestor and then something else doesn't quite match up. Well, does it actually match up if you look at branches instead of ancestors? Does that make sense?
Yeah, it makes sense.
It's hard when you're not looking at chromosomes.
Catherine's got a comment here that's very helpful that I think might clarify. I don't remember if I was responding to Dale, but someone was asking about whether you can use the tools at MyHeritage. And Catherine's comment is, I think you need a paid subscription to use the DNA tools. And yes, if that was the question before, of which maybe I misinterpreted that, I think you do need to have a subscription to use these more advanced tools at MyHeritage, but I'm not exactly sure. Do you know, Catherine? Jennifer?
The advanced tools are part of one of the subscriptions.
Okay.
Or if you uploaded, if you transferred results early enough, you've been grandfathered in to have access.
Okay.
So people are going to go, no, I don't have a subscription. I have access. You got grandfathered in with access. So, but you can no longer get that expired.
Clement says, the most useful DNA webinar I've attended to date. Thank you. What's the minimum size in cm to look for a pileup region? Is 15 to 20 centimeters too centimorgans? I'm sorry, guys. It's been a lot of information today, so you'll have to forgive me for these slips of my tongue. Is 15 to 20 centimorgans too small? Again,
That's
this is
too big
for a pileup region.
Yeah. When you hear other people talk about pileups, they're lots of times talking about 8 centimorgans. Okay. It's usually applied to a very small amount. Like I said, those ones that I showed you are huge in comparison. Some of those are over 50 centimorgans. Like I said, that was also coupled, because I only uploaded over a certain size. That was coupled with what I knew about the family tree, and me going, this is too big. There's no way this is going to match up. So normally they are very small segments, and you can't fit it on a screen. It will just keep going. There will be so many of them. And that is traditionally what is meant by a pile-up. And I have applied it in this case for the same thing at a larger size, meaning, oh, I see the surname. I'm not going to work on this right now.
Okay. And Dale is saying that he has a subscription at MyHeritage, so he's all set in that regard. So, all right, well, at least we got it clarified perhaps for somebody else. But thank you, Catherine, for your comment. Okay, so Brian is sharing the link. Thank you, Brian. It was Stephen, and his original question was answered. Thank you. I'm just going here and trying to see if there's any more questions. Okay. Charles says, when you say build trees for your matches, you mean looking at census reports. So you're talking about doing the documentation and the paper trail, right?
Yep. You don't get out of that traditional research just because you're doing DNA. And what I like to remind people is, you're a genealogist, right? You love doing research. I just gave you permission to do as much research as you want. I do most of my tree building just with online records. It is very helpful to have a paid subscription to do it. I will tell you that. I let my Ancestry subscription expire on purpose to see what it would be like, and it was miserable. I couldn't build DNA trees. But it's much more fun because you're not constantly being frustrated running up against the same brick wall you've been running up against for 10, 15, 20 years, because you're getting to work on different branches, and you're knocking out all the easy research as fast as you can. So you're getting to do what you love even more. It's an unending stream of trees to work on. So look at it as a fantastically exciting thing.
All right. Cynthia is helping us out here with that whole downloading DNA triangulation question that Zoe had. She says, downloading the MyHeritage triangulation information, go to advanced options, and you can download the shared match information for the selected matches. I'm not sure if Zoe was trying to download all the triangulation information or what. But anyways, that helpful hint there from Cynthia. So thank you, Cynthia. A little suggestion here from Sandy. She says, Marion, please do a text zone on building matches trees, multiple and detaching to a DNA matches private tree. So thank you for that suggestion. For those of you who don't know, Text Zone are our new short videos for members. They're 10 minutes or less, and people are finding them really helpful for DNA because they only cover one concept at a time.
Yes.
Unlike today's webinar.
Yeah,
But
today was like, here's all the things that you need to put together.
exactly. This is a really meaty webinar. Let's see. Oh, Lisa is asking, is there a website that lists endogamous groups?
I do not know the answer to that. Like I said, not my specialty. So Google it.
What is that website that Blaine always refers to? The international, that website.
The ISOG wiki.
Yeah, that probably would be the closest
If you
thing to
Google
having.
it, usually those ISOG ones are some of the first ones that come up. That's actually why I usually just Google it, is because it'll break those down really fast for you. Because it's obviously a wonderful website. So Google really loves it.
Yeah, that would be my suggestion. So if anybody has the link for the ISOG wiki, if you want to put that in the chat, I can share that out. Let me see. And yeah, a lot of people are asking here about endogamous populations like the Amish and the Mennonites and things like that. I'm not going to bother Jennifer with that because she already said that her focus is on the Southern DNA groups. So you could go to the Genetic Genealogy Tips and Techniques group on Facebook. If you don't know what that is, somebody could put that in the chat for me real quick, and I can share that out as well. Oh, thank you, Dale, for sharing the ice. Oops, I gotta. That group is just terrific. The Genetic Genealogy group, and that you could go there and search it. You know, put in Mennonite, put in Amish, put in Cypress, and that would probably get you started. And then if you don't find what you're looking for, then you could ask the group. That would probably be what I would suggest for some of these, things. If anybody can get that URL real quick for Genetic Genealogy Tips and Tricks, that would be great. And in the meantime, I think we have thoroughly exhausted Jennifer's knowledge here. We made you work so hard today. Any parting thought for us, for our audience today?
I really want to emphasize about the focus. That is the thing that I have found so many people that are like, I've worked with some people that are just really brilliant. Some of them have even biology degrees. They know more about DNA than I do from a biology standpoint. They understand a lot of the underlying stuff. My background is statistics. That's why this makes sense for me. But they didn't focus on something. And when they focused, they would make these massive breakthroughs. And so that is a big thing. It's so easy to like bounce around all this different stuff because you're trying to figure out what's going to work. But sometimes you just have to stop and focus. And like I said, it doesn't mean you have to focus for a year, a month. It can be one session of work time that you're going to focus, and make sure that you're considering both that methodology and, the tree related focus, focusing on a branch, focusing on a person. It doesn't really matter as long with DNA is very different than making a traditional research plan. A traditional research plan, we narrow it down. We're not even talking about a person. We're talking about one fact for a person. DNA can be much broader than that and be an excellent plan. But you don't want to just be saying, I'd like to find something. Because if you don't get more specific than that, you probably won't.
All right. Well, thank you, Jennifer, so much for a wonderful, really thoughtful presentation today. Thank you to MyHeritage for sponsoring these presentations. Without them, we wouldn't have had this webinar. And because it is a MyHeritage series webinar, it will remain free. So be on the lookout for that. You'll see it at Legacy Family Tree webinars later today, and then it will make its way over to the MyHeritage Education Center as well. Maria is asking, am I going to be here tomorrow? No, tomorrow you have the pleasure of Jeff's company. I would just like to say to everyone, there's a lot of information that was shared in the chat today. So you can go to your GoToWebinar control panel. At the very top, you'll see it says File. Click on that and then do Save Chat Log. And that will save all of these URLs and all of the information that was shared today. And I'll just save this group URL one more time. There we go. So go to File, Save Chat Log, and that will save everything that went through the chat today in a text file that you can access on your computer. All right, that's going to do it. I hope we'll see you at the next MyHeritage webinar with James Tanner. Thanks, everyone, for being here today. Bye-bye.